Let's take a look at how we can configure ERSPAN. That's Encapsulated Remote Span, and ERSPAN has the advantage of allowing us to monitor traffic across router boundaries. In this example, let's set up switch SW1 and SW2 to be an ERSPAN source for SW1 and an ERSPAN destination for SW2. And something to be aware of if you want to practice this on your own, ERSPAN is not supported on every Cisco switch. A lot of the lower-end Cisco switches are not going to be supporting ERSPAN. For this demonstration, I'm using virtualized Catalyst 8000s. You could also use a CSR 1000V, and there are a few more higher-end devices that will support ERSPAN, but I didn't want you to be surprised if you were trying to do this on a lower-end Cisco Catalyst switch, and these commands aren't working for you. They're only supported on some of the higher-end devices. And when we talk about the theory of ERSPAN, we say that we're taking traffic from a source port or source VLAN on our source switch, SW1 in our case, and we're sending copies of traffic across a GRE tunnel, but we're not actually setting up a GRE tunnel. That's sort of done in the background. What I want to do in this video is set up ERSPAN and then prove that we really are sending GRE encapsulated traffic over to the network monitor. And to get started on SW1, let's go into global configuration mode, and I'll set up a monitoring session. I'll say monitor session 1, and the type is ERSPAN source. And you guessed it, SW2 is going to be an ERSPAN destination. Also, the session number is locally significant. It does not have to match on SW2. And I'm going to say that my source interface, off of which I'm capturing traffic, is going to be interface gig 2. I'll do that in both directions. And something unique about ERSPAN is that it is administratively shut down by default, unlike local span or RSPAN. So I have to do a no shutdown. And I've specified my source interface. Now I want to specify information about my destination. So now I'm in ERSPAN source destination configuration mode, and we're not going to be configuring a GRE tunnel where we create a virtual interface and specify remote IP addresses and things like that. Instead, we're going to create an ERSPAN ID that does have to match on both switches. And I'm going to say my ERSPAN-ID is 100. That will have to match on SW2. And I'm going to specify the eventual destination of this traffic, which is my network analyzer. That's an IP address of 192.168.1.150. And the IP address on SW1 that I'm going to be using to do the initial encapsulation of this captured traffic and send it over to the network analyzer, that's going to be my WAN interface. It's IP address 172.16.1.1. And I'll say origin IP address 172.16.1.1. And we're done with our configuration on SW1. Let's do a show monitor session 1 to verify our configuration. We see that this is a source session. We're administratively enabled. We were disabled by default. We're capturing traffic from gig 2, sending it to 192.168.1.150, our network analyzer. The IP address of the interface that's doing that GRE encapsulation is 172.16.1.1, and that's all identified by an ERSPAN ID of 100. Now let's go to SW2 and set up the destination side. We'll say monitor session 1. That did not have to match. That could have been a different number, but I'll say monitor session 1. The type in this case is ERSPAN destination instead of source. Let's administratively bring it up with a no shutdown command. My destination interface, off of which my network analyzer resides, is interface gig 2. Now let's specify the source information, and the source information is primarily contained in that ERSPAN ID. I don't have to know the IP address of anything back on SW1. I just know that I'm receiving this GRE traffic, and it's part of this ERSPAN ID of 100. And probably the most non-intuitive command in this entire configuration is when I say in ERSPAN destination source configuration mode, I'm saying IP address, and the temptation here is to give the IP address back on SW1. But actually, this is the IP address of the network analyzer. It's 192.168.1.150. And we're done. Let's verify our configuration with a show monitor session 1 command. We see that this is the destination side. We are administratively up. We're sending traffic out of gig 2 specifically to 192.168.1.150. And we're getting traffic from this ERSPAN ID of 100 coming in from SW1. Now let's generate some traffic that will cross that gig 2 interface back on SW1. I'll do a continual ping to 10.1.1.100. That's the server. And let's see if we can see GRE traffic coming into this network analyzer. And on the network analyzer, let's say sudo TCP dump protocol GRE. Am I capturing any GRE traffic? Let's give it a moment. In fact, let me go back to my PC. I will stop and restart this ping traffic. And there we are. Notice that we're coming from that WAN interface on SW1 to our network analyzer, and the protocol is GRE. We did not set up a GRE tunnel, yet we're encapsulating traffic that's being captured inside of GRE so we can send it across router boundaries. And in this example, I'm using a TCP dump for my capture. That's not going to fully decapsulate those GRE packets and make it easily readable to me. But if I were using something like Wireshark on my network analyzer, it does have the ability to show us the contents of those GRE packets. But in this demonstration, I just wanted to prove that we really are encapsulating this captured traffic and sending it across router boundaries using GRE.